work on tonight?
Well, right now in my class, we don't have any homework to work on. We're just going over tangent graphs and cotangent graphs.
Okay.
If there's anything you want to go over there. And then otherwise that, I'm taking the ACT this weekend, so I was hoping we could just study for that a little bit.
Okay. Let's just talk about the tangent and the cotangent graphs.
Okay.
And how they differ.
Mm-hmm.
First of all, the tangent graph sits between asymptotes that go from minus pi over 2 to pi over 2.
Okay.
And then every pi after that, there's a vertical asymptote. The period of the tangent is not 2 pi, it's 1 pi.
Okay.
Okay. Now, and let's label this y equal tan x. And if we look at the cotangent curve, its asymptotes go 0 to pi.
Mm.
And then every pi after that. In other words, there's a vertical asymptote right there. And the cotangent curve is always decreasing.
Okay.
So notice that it is almost a reflection of the tangent curve.
Okay.
Which is somewhat problematic, because if they show you a curve and it looks like my green curve and they don't give you where it's at on the horizontal axis, then you have no way of knowing whether it's a cotangent curve or a negative tangent curve.
Okay.
If I went over here to my drawing on the left and I wanted to draw a negative tangent curve, it would be that. It's the reflection over the x-axis.
Okay.
So the only thing that separates this green line from this green line over here is the one on the left is going from minus pi over 2 to pi over 2, and the one on the right is going from 0 to pi.
Okay.
If you can figure out what it is, where it's located on the horizontal axis, then you can distinguish between a cotangent curve and a negative tangent curve. Likewise, the tangent curve, if I were to take a negative cotangent curve, it's going to have exactly the same shape as the tangent curve is. Negative cotangent has the same shape as positive tangent. Because if I reflect this green line over the horizontal axis, it'll look just like the tangent curve, except it won't be in the right place. In other words, if I were to just give you a curve like this and say, what is that? Well, you would know that that's a negative cotangent curve because it's running from 0 to pi.
Yeah.
So that's all I really wanted to say about tangent curve and cotangent curve.
Okay.
Graphing them is relatively easy, but the harder part is when they give you a graph and they ask you, what is it? Because the first thing you have to distinguish is it, where is it at? Is it going between minus pi over 2 to pi over 2? And of course, this one has another asymptote at 3 pi over 2. It all's going to have to do with where it lies on the horizontal axis.
Okay.
Okay?
Okay.
All right. Let's bring out the ACT test here. I think I made a note on where we left off. Nick D. Yeah. question 15 on test 1. Okay. And I don't know whether it was, I think it's these tests 1 over here. Yeah, let's see what 15 is. Nope, not quite. Must be this page. Yeah. Did we do this 15? I don't know if you can see that or not. We 14. Which of the following is the decimal equivalent? I don't remember doing that with you.
No, I don't think we did that 15.
Let me make sure I'm on the right test here. Did we do this 14? I don't think we did any of it.
No.
No, I think I was probably in the McGraw-Hill packet. So let me go to there. Yeah, I believe we did this 15.
Yeah.
Okay. So let's look at 16. Now, I wasn't even positive. When I made that note, I wasn't positive how far we had gotten, but I thought we'd gotten through 15. We haven't done,
did.
Yeah, we didn't do 16, right?
So, okay.
Can you do 16 real quick? It's pretty straightforward. Yeah, and don't be confused by their wording. For all x is the same thing as saying, what is 7 minus 2 times parentheses x minus 10 end parentheses equal to?
Equal to. Yeah.
So what is it equal to?
I'm figuring that out right now. 2x 20 equals 7 2x plus 13
plus 20, right?
Yeah.
Okay, so what's that?
It's just negative 2x plus 27.
And that's one of the answers. So
cool.
I would go with that. Don't spend a whole lot more time on it than that. This one, 60%. I feel like we did this one also.
Oh yeah, I think we did this one.
Yeah, you remember the answer?
I think it was 150, wasn't it? Yeah, it was 150.
Yeah. And we basically don't really need to do any math here. 60% is a little bit more than half. So x has to be a number, greater than 90, but not greater than 1,000. So 150 is the only answer on there that can even be close.
Plausible.
Correct. 60% of 150 equals 90. If I wanted to do it mathematically, I would write it, if I wanted to do it algebraically, I would write it like this. 60% of z equals 90, so z equals 90 divided by 0.6, which is 150. When you're doing these problems, of means multiplication, equals means equals, or is means equals.
Yeah.
Did we do 18?
Yeah, we did. I think the answer came out to 185.
Yeah, I remember doing 18. The reason I couldn't quite remember is I'm working with a few students on ACT now. So
no, that's okay.
Remembering where we got to, I need to be more accurate in my note that I made.
Yeah, that's okay.
I know we didn't do 20. I don't believe
we didn't do 19.
Yeah, 19 is kind of a good problem.
Okay. Oh man. $21 bills.
What's the, okay, let me help you through this a little bit. What's the quickest way to figure out the cost of the two lamps?
Just add $8.99 plus $8.99.
Oh, with the 7% sales tax.
Add $8.99 times 2 divided by 0.7.
Well, not divided, multiplied by.
Oh, multiplied by
If I
0.7.
multiply that by 0.07, I'll get the amount of the tax. And then I can add that to the cost of my two lamps. But the easier way to do it is to multiply the whole thing by 1.07, and then I get it in one step.
Okay.
So what do you get when you do this? 2 times 8.99 all times 1.07.
Sorry, I'm just getting out my calculator real quick.
Okay. And you do see that that's the same as multiplying 0.07 and then adding it to the original cost.
Because it just puts it all together.
Yeah, it saves you a step. You don't have to do the addition if you multiply the whole thing by 1.07.
19.2386.
Okay. Now let's look at the question. You have $21 bills. How much will you need in coins if you want to have exact change ready?
Wouldn't you need 24 cents?
Yep.
Okay.
And they did put the trap answer on there, 76. In other words, it would be real easy to misread this and say, how much change do you get? Well, if you took your 20 bucks and subtracted your cost, you're going to get 76 cents. So they do put the trap answer on this question. So you have to be really careful about reading the details on these. Notice that, I guess the 2 was key. Oh, all right. Let's look at 20. R cubed equals 343. They want to know what 3R equals.
Does it 3R equal 21?
Uh-huh.
Okay, cool.
Can you place those 3 numbers from least to greatest? And what's the secret in doing it?
Maybe getting a common denominator?
No, we don't even need to do that. Let's convert each one to decimals. In other words, it's hard to compare pi with 7/3 because pi is pi, but we can approximate it with a decimal, but it's hard to approximate with a fraction. So let's write pi as 3.14. And now give me a decimal on 7/3.
2.33.
And now give me a decimal on 9/2.
Like 4.5.
Now it's easy to order the numbers.
Okay.
7/3 goes first, pi goes in the middle, and 4.5 goes on the right. So
it'd be B.
B, exactly.
Okay.
That's another good one.
What number can you add to the numerator and denominator of 314 to get 3/4?
So 9/13 to get 3/4.
9/13 to get 3/4.
In other words, what they're saying is there any numbers in this list that I can add to the numerator and the denominator and end up with a fraction that's equal to 3/4?
If you add 3 to the denominator, you get 6 and 12. Isn't it 3? Or J?
Well, you would get 12 over 16, which, yes, is 3/4. Exactly. Now, This problem is much easier solved by back solving like you did it than by
Mm-hmm.
algebraically attacking it. First of all, you got to figure out how to algebraically attack it.
I don't know how.
Well, here's how you would do it. I'm going to add some number, which I'm going to call x,
Yeah.
and now I just have to solve that for x, and I would solve and get 3 as an answer.
Mm-hmm.
But first of all, it's difficult to formulate this. Second
Mm-hmm.
of all, it's not that easy to solve it. There's a lot of math that you got to do there. You got to cross multiply, distribute, gather all your x terms on one side, your numbers on the other. There's a whole lot of math.
Yeah.
Your solution took you about 10 seconds.
Mm-hmm.
Now, if the answer would have been one of these fractional numbers, your solution is going to take a little bit longer. We were a little bit
Yeah.
lucky in that you started with the easiest math. In other words, there was a
Okay.
reason you started with J, because it's easy to add 3 to top and bottom. You didn't start with H because it's tough to add 1.5 to the top and 1.5 to the bottom and simplify.
Yeah.
Okay? But I'm not sure that you can count on always knowing that you're going to have an integer answer here. If the answer was this, well, now I just have to figure out how to put this. That's 3 halves and 18 halves. So that's 21 halves in the numerator. And this is 3 halves and 26 halves. So that's 29. And now flip and multiply, and I get 21 over 29, which is not 3/4.
Mm-hmm.
21 over 28 would be 3/4. Okay? So in other words, if the correct answer was fractional, then it's going to be a little harder than it was with the correct answer being an integer, which is
Yeah.
exactly why you should start with the integers. In fact, you might want to start with 6. The math is real easy to do for the integers. You could
Mm-hmm.
do 6, you could do 3, you could do -3. If none of those work, then I go to the positive fraction. If that doesn't work, then you know what the answer is and you're done.
Yeah.
But as far as which one to start with when you're back solving, there's lots of rules and criterions for that. But in a problem like this, you want to start, there's no rhyme or logic for starting with any of those particular answers. Any of them could be equally correct.
Mm-hmm.
So we start with the ones that the math is the easiest.
Okay.
In case it is a whole integer, we're going to be done with the problem in 10 seconds or 15 seconds.
Okay. Okay.
And that is a problem that would be hard to formulate even. And that's usually the case. Usually when you're looking at problems that are hard to formulate algebraically, they're almost always easier to do by back solve because there's no
Yeah.
problem back solving it. You know exactly how to do it. You add that number to top and bottom and see if you get 3/4. All right, 23. Classic problem. You might run into this problem
Um,
4 times on the test, or it
it
might
feels like,
in a different form, but you got to know how to figure out slope from 2.
what is the slope line joining the points 5, 4, and 2/7? Is it asking for the equation of the slope line?
No, they just want the slope. What is the slope? So
Um,
slope. Tell me what slope is.
rise over run.
Okay, now translate that to a more detailed equation.
Y2 minus y1 over x2 minus x1?
Yeah. Notice that you don't really have to memorize that. You can always work this out from rise over run. You know,
Yeah.
10 years from now, you want to remember that it's rise over run. You may not remember y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But you'll remember rise over run and you can figure this out. So for this problem, what's y sub 2?
Negative 7 minus 4 equals negative 11 over 2 minus 5 equals negative 3. So it'd be 11 thirds?
Uh-huh.
Okay, that's B.
Notice you can actually do these in any order as long as you do top and bottom in the same order. In other words, you can do y sub 1 minus y sub 2 if it happens to be more convenient, you know, if you happen to produce nothing but positive numbers doing it this way, and sometimes that'll be the case. Then it's perfectly okay. You'll get the same slope using that formula. What you can't do is do 2 minus 1 in one at top and 1 minus 2 in the bottom.
Okay.
As long as you go the same way. In fact, in this problem, it actually would have been a little easier to do it this way, right? Don't have, you ended up with 3 minus signs. Well, if we do it the other way, it's 4 minus a minus 7, which is 11, and it's 5 minus 2, which is 3. To get it maybe a little easier.
I see how that goes.
Merely because I don't end up with a negative divided by a negative. You know, the more often you can deal with positive numbers as opposed to negative numbers, if you have choices, that's what you should do.
Okay.
24. Question on prime numbers, which is
greatest prime factor of 38, and f is the greatest prime factor of 100. So I have to know the prime factors?
Let's see. This is a tough problem just to figure out. If p is the greatest prime factor of 38 and f is the greatest prime factor of 100, well, we have to figure out what the greatest prime factor of 38 is and what the greatest prime factor of 100 is. So let's start with 38.
It could be divided by...
This is the way they have you do it?
Yeah, the pyramid.
So that's 19 and 2.
So the greatest prime factor would be 19,
correct. Right? Now let's figure out.
And then 100 would be 50 and 2, and then 2 and 25. Would it be 25? 19 plus 25?
Oh, 5. In other words,
5 and 5.
You have to break it all the way down to a prime number.
Yeah.
In other words, I keep going until I cannot split this thing anymore. I can't split 2, but I was able to split 50 into 25 times 2, and I'm able to split 25 into 5 times 5. So 5 is the greatest prime factor. 19 plus 5 is 24.
BH. Okay, 24. H. I see.
That's why I chose this test, because it's got some really good problems on it. This is another really good problem.
So t plus v squared equals 289, and t times v equals 30. So I have to find something that adds up to be 30, or multiplies to be 30, but adds up to be something that's 289. So why don't I just do the square root of 289 real quick?
Okay. That's 13? No. What is that's
17.
17. Okay.
So I need something that adds to be 15 and 2.
V equals 17, right?
Yeah. So then if I want to do something that multiplies to be 30, I have to do 15 and 2. And that multiplies to be 30.
But they want t squared plus v squared.
So if I do 15 squared...
You got a lot of possibilities, right? It could be 15 and 2. Well, maybe that is the only possibility.
No, because it has to equal 30. That's for the multiplication.
Right.
Yeah.
Right.
So if I do 15 squared equals 225, and 2 squared equals 4, so it's 229. E.
That's pretty clever. I don't like that solution, but you got the right answer. Now, let me tell you the way this is meant to be done. I don't know. The more I think about it, first square that. What do you get?
T plus V squared?
Uh-huh.
T squared plus V squared?
No.
Or TV squared?
No. It's the most common mistake made in algebra. When you're squaring a binomial to say that the answer is a squared plus b squared. It's not. Foil that. Multiply plus v times t plus v.
Oh, okay.
You get t squared plus 2tv plus v squared.
Okay.
Okay? And we happen to know what a TV is. A TV is 30. So now we can say t squared plus 2 times 30 plus v squared equals 289. Means t squared plus v squared equals 229.
Oh, okay. I see how that.
Okay.
Okay.
Now, let's talk about that for a minute because this is extremely useful to know. Both of what I'm about to write here. That's true, and then you have to do this one a lot too. You have to square the difference of two terms, and the only thing that's different is the sign on that middle term. Okay? So if I said, what is 3x plus 2y squared, you could do it quickly by using that. You wouldn't have to FOIL it out. You would just know the first term is 3x squared, which is 9x squared. The next term is 2 times the a times the b, that's 12xy. And the last term is this term squared, plus 4y squared. So there's your answer, using the binomial theorem, basically. Now, how is this going? Well, let me give you a problem that I ran into on one practice test. What's this number equal to? And I venture a guess that that would even be hard to come up with on a calculator. I mean, if you had a pencil and paper, it might not be that hard, but still not going to be that easy to do even on a calculator, right?
Yeah.
Notice what that is. That's got to be 100 minus 99 squared. Because this is a squared, that's the 2ab, and this is the b squared. So I know from the formula that that is a minus b quantity squared, which is 100 minus 99, which is 1. So the answer to this thing is 1. And I get it without doing any arithmetic at all. I get it by knowing those two formulas that I drew. These two formulas here are well worth memorizing. You might get problems in all kinds of manner. You can't always be sure that you're going to get the left, that you have to solve for the right. Sometimes they'll give you the right, and you got to solve for the left, like the problem I just put up. But definitely worth knowing if for no other reason that it makes it easy to square binomial terms. Notice that it was relatively easy for me to square that rather complicated binomial term.
Yeah.
By following the formula.
Okay.
Okay. And it avoids you making that most common mistake. What is x plus 1 squared? And 90% of my students would say x squared plus 1 immediately. But it's not.
Yeah.
What is it?
X plus 1 plus, or times x plus 1.
Well, use the formula to figure out what the answer is. In other words, don't actually go through the FOILing process, because that's the whole reason to memorize these formulas.
It would be x squared plus 2x plus 1.
Yeah. Exactly. Okay. Cool.
Okay.
26.
26. If for all, oh my gosh.
Again, don't get confused by those first 4 words.
Yeah.
What they're really saying is, what is this equal to? How do you...
Not even without the x minus, or x equals 44 squared?
Well, it's true. First of all, we have to do this. In other words, you have to figure out which rules of exponents to apply.
Oh, wait a second. Okay.
So this left side. What is that going to be equal? You're right. It's equal to x to the 4.
Yeah.
But once we do our rule of exponents, then we'll be able to equate exponents and solve for a.
So you multiply them, so it becomes 12a plus 20.
Yep.
12a plus 20 in the rule of exponents, if they're the same, I can't think of what it's called right now, the same thing in front, you know.
Yeah, you can, in other words, if it's the same base to one exponent equals the same base to a different exponent, then you can equate these two exponents. And you get 12a equals
44. Or 24.
So a
equals 6.
2.
Oh, 2. 2, sorry.
Okay. Yeah, the rule of exponents that you need to know is that when you're doing a double exponentiation like this, you multiply the exponents.
Yeah.
Okay, here, I'm going to give you a fun problem.
Okay.
If you can get this, I'll be very impressed. No parentheses.
Huh.
What do you do when there's no parentheses? In other words, if it was this, then I would multiply 3 times 3, the exponents, right?
Yeah.
Okay, but there's no parentheses. When there's no parentheses, you work from the top down.
Okay.
Guess what this is? Guess what the answer is? Just a wild guess. I bet you're not within a billion.
1?
Okay, I should have said you're not going to be within 7 trillion.
It's
7.6 trillion is the answer to that.
7.6 trillion?
Isn't that fun?
What?
Well, let's do the right side. Start from the top down. 2 squared is 4, so this is the same as 2 to the 4th. So this number is 16. Do the left side. 3 cubed is 27, and 3 to the 27th power is 7 trillion.
Oh.
You have 7 times 10 to the 12th. It's got 12 zeros. So you have 7 trillion minus 16, still 7 trillion.
Yeah.
This is kind of cute, only it's not something that you're going to be given on a test. I happen to be doing some research on large numbers, and this is notation that is used to talk about extremely large numbers. more so
Oh,
than scientific notation. I mean, you can use scientific notation, times 10 to the 200
yeah, yeah.
power.
Uh,
Another good one is 50 factorial. What do you think 50, you know what factorial means, right?
yeah.
50 times 49 times 48, so forth. Take a wild guess as to what this is.
Oh man. Quintillion? Something quintillion?
Not 63rd power.
Oh wow.
50 factorial is greater than the number of molecules in the universe, which is estimated to be about 10 to the 50th. Now, how strange is that? That 50 factorial would be that big of a number.
Huh.
You wouldn't think it's possible almost.
Uh-uh.
I mean, if you think about 50 times 49 times 48 all the way down to 1, how do you get this size number? But trust me, it's true. Sorry, I didn't deviate.
No, that's okay. It's interesting.
It is kind of interesting stuff, especially the 3 to the 3 to the 3. And that's why they use 3. They don't use 2. When they talk about really, really large numbers, they use 3 because it gets up there super quick.
Yeah. Okay.
So, add logs. What does x need to be?
Which of the following value of x is satisfies log? Oh, hold. Sorry, I'm just getting my pencil and paper. Log x to the 16th equals 2.
Remember how we always figure out log problems as we turn them
Yeah.
into an exponential expression?
Uh-huh, you got, yeah.
Equivalent exponential expression for this.
16. It'd be 2 to the second equals 4, 2 to the third equals 8, 2 to the fourth, so x equals 4.
Well, it's x to the 2 equals 16. So you're right.
Oh,
4.
so
But
it'd be 4.
when you're going to the exponential expression, it's the number on the far left raised to the power of the number on the far right equals the number in the middle.
Yeah.
The log is on the left side. If
Huh.
2 equals log x of 16, then you can't use that little technique.
That's kind of funny. I messed it up, and I still got the correct answer.
Squared. Yeah, it is a little funny, isn't it? It's because x squared and 2 to the 4th are the same thing.
It's kind of funny if I looked at my, like...
X squared are the same number, 16.
Yeah, if I looked at how I did on my paper, too, it even, like, shows I drew a little loop, and it has x going to the 2 to the 16th, so that means x to the 2 power.
Always remember one thing about logarithms. They are exponents.
Mm-hmm.
So you know the 2 has to be the exponent.
Yeah.
Not the base. Never the base. And in fact, if you remember that logs are exponents, that always directs you properly as to how to convert between logarithmic and exponential expression, which is what you really need to be able to do here.
Yeah.
You got it accidentally, which that'll happen about once every 7 trillion times, where
Yeah.
you make a mistake and it turns out that it gives you the correct answer.
Yeah, that's kind of lucky.
So that, well, yeah, that's very strange that 4 squared is the same as 2 to the 4th. But how often is that going to happen? So,
Not often. Yeah, okay.
okay, about 28.
One endpoint of the line segment, xy coordinate. Midpoint of the line segment. Okay, so...
Not sure you have to draw a picture here, but it's very helpful.
Yeah.
Let's put the first one on there. Now, what you definitely do not need to do is grid it.
Yeah.
In other words, do not waste your time putting a grid on there. Just approximately put where that point is, always.
Uh-huh.
Okay, and the midpoint is at 4, 4. Let's call that 4, 4. So
Yeah.
the other end is going to be somewhere up there, right?
Yeah.
So what's the coordinates on the other end?
4 plus 6. It is 10, negative 1.
Yeah, very good. And the drawing it told us that which direction to go, basically. In other words, you figured out that to get to the midpoint, you had to add 6 to the x-coordinate, and you had to subtract 5 from the y-coordinate. So you
Yeah.
keep doing that to find the other end point. What you know is that this segment is equal to this segment.
Uh-huh.
Okay.
And I did the x first, and I did
And
negative 2 of 4.
that's all you really needed to do.
Yeah, because 10 was the only answer.
X, there's only one answer on there that has 10.
Uh,
So you could have saved yourself a few seconds. And let me just make a comment about this. It's always worth looking at the answers before you tackle the problem.
yeah.
Because notice these answers, all of them have different x-coordinates except for f and k.
Yeah.
So that would have immediately led me to believe that f or k was correct. But not so here. In other words, if I was back solving it, I would have started with f and k, figuring that -8 was probably the correct x-coordinate. But it isn't, and once you figured out what it was, then you're done. 10 tells you the answer without doing the math for the y. But you wouldn't have known that unless you looked at the answers. In other words, if you just plow into the algebra of the problem, which we did, we come up with the answer. We didn't need multiple choice here. But sometimes when they give you multiple choice, it allows you to shorten the length of the problem. Still with me, Nick? I'm not sure if I lost audio or not. Nick?
Sorry, I was talking to my mom, and I thought I took it off mute.
Oh.
My bad about that.
No problem.
Okay.
Sometimes it feels like I lose audio, and I've been known to talk for like 3 minutes, and the other person's been disconnected for 3 minutes, and then I never know what part of what I said they heard. So,
oh no, yeah, I caught it.
If I hear any sound, I usually ask, do I still have audio?
Yeah.
Okay. How about 29?
In an xy coordinate plane, what is the radius of a circle that is x?
The ACT test is going to ask you 2 conic section questions.
Okay.
Okay. And they're only going to be on circles and ellipses. They won't be on parabolas. They won't be on hyperbolas.
Why nothing else?
Well, because they're hard. Whereas circles and ellipses are easy. So let's just review the 2 general formulas. What's the general for a circle?
A squared plus, or x squared plus y squared.
Well, that's if the origin, if its center is at the origin, then it's just x squared plus y squared. If its center is not at the origin, then this is the general formula. Equals what?
Equals 1.
R squared for
R squared, sorry.
Circle. For an ellipse, it's x minus h squared over a squared plus y minus k squared over b squared equals 1.
Okay.
So you need to memorize those 2 formulas.
Okay.
Now that we have it memorized, they're giving us a circle. What's the radius of that circle?
Square root of 14.
Yep.
Okay. That's pretty easy.
Yeah. If you know your general formulas, that's the secret to all math, really. Any problem that I come across where you need to start it with a general formula, I generally tell everybody you should start as many math problems as you can with the general formula and then plug in everything you know about that problem. And you'll usually be left with just one variable. And that last one, you didn't even need to do that. The last one was just knowing that Well, you needed to know the general formula was equal to r squared. You needed to know that.
Yeah.
There are also 4 trig problems on the test. So you're in good shape there because these are all easy trig problems. None of them are hard. They're trig problems that you should be able to answer having not just after taking geometry or algebra 2. In other words, you don't need to take trigonometry. They teach you enough trig prior to taking the pre-calc trig course you're taking that you should answer all of these trig questions.
This first one is H, 12 over 13.
Okay. And they get a little bit harder than that, but not much.
Okay.
Okay. You don't have to know your identities. Probably need to know your 6 reciprocal identities and SOHCAHTOA, and maybe a little bit about the unit circle. I have seen some questions that, you know, what quadrant are you in if this and this and so forth. So, all right, third.
This one's kind of confusing, but
well, it doesn't need to be. Here's why. When you have a problem like this that has numbers and 2 different variables, take it one piece at a time. Do all your numbers first.
So 13 times negative 8.
Hold on. Let's make sure you do these properly.
Okay.
The way to do this problem is not to multiply 13 times negative 8. It's to simplify it first. In other words, divide top and bottom by 4. Turns that into a 2, turns that into a 1, and now you know minus 26 is the result. And I didn't need a calculator. Now, I understand that you're allowed to use a calculator, I think, throughout the whole test. Am I correct?
Yeah.
So these little tricks aren't as important for the ACT, but when you take the SAT, they will be, because they give you a whole section on the SAT where it's a non-calculator section. And you certainly wouldn't want to have to multiply 13 times 8 and then divide the whole thing by 4 manually.
Okay.
Now so that tells us quite a bit. It tells us the answer has to be either B, D, or E, because this minus 26 ends up in the numerator. Okay? But getting the whole answer is really easy. Let's do the A's. What's A squared times A cubed?
Does it become A to the 5th?
And what's A to the 5th divided by A squared?
A to the 3rd.
So
and that gives you your answer pretty much, doesn't it?
What's that?
Doesn't that pretty much give you your answer?
It does. It has to be B.
Mm-hmm.
And again, you don't need to do the 3rd variable. In other words, by the fact that they didn't put multiple minus 26 A cubes on there, they don't make you do the B. The B is easy enough to do. B to the 4th times B to the 5th is B to the 9th. Divided by B to the 6th is B to the 3rd. So it's not hard to do, but you can see that they give you problems that you don't actually have to completely solve. 32 is an interesting, well, go ahead.
I want to say K, but I don't know if that's correct.
Well, what's an isosceles triangle?
Oh, wait a second. Isn't an isosceles triangle just a triangle with all sides the same?
That's equilateral.
Oh, no.
Isosceles is two
sides the same?
Sides, 2 equal sides.
Okay, so it would have to be K, correct?
Almost. You're close. G happens to have 2 equal sides also.
Oh.
G has 3 equal sides.
Okay.
And they called this a right isosceles triangle, and the right angle has to be there, which means this side here cannot possibly be equal to the other 2 sides. This This
Okay.
side here is a hypotenuse of the triangle. So it has to be the largest side. So that means K has to be the answer.
Oh, okay.
And let's just talk about another principle for triangles. There's one rule that doesn't get enough talked about in geometry. That is, any side of a triangle has to be less than the sum of other two sides
Okay.
and greater than the difference of the other two. And notice that I didn't really have to remember the second part. I just had to know that it was the reverse of the first part. In other words, if I remember this part right here, I always know this part down here because I know that I switch the direction of the inequality and I turn sum into difference. Okay? And what they're saying is, can I have a 2, 3, 4 triangle? Well, that side is less than the sum of those two, so it passes test 1, and it's greater than the difference of those two. So it passes test number 2. 3 is less than 2 plus 4, that's true, and 3 is greater than 4 minus 2, so that's true. And 4 is less than 2 plus 3, and it's greater than 3 minus 2. So you could have a triangle with sides 2, 3, and 4. Not a right triangle, but just a triangle. Could you have this triangle? 2, 3, and 5. A triangle with those kind of sides.
I don't think you could.
No, every single side fails one of those tests.
Yeah.
2 is less than 8, but it's not greater than 2. These don't say less than or equal. They say less than. So I flunk on the very first side. This one also fails because it's not greater than the difference. And this one fails because it's not less than the sum of the other two.
Yeah.
And you might get problems like that where they give you 3, or they'll give you a problem. They'll say, which of the following could be a triangle?
Okay.
Something very similar to 32. Which of the following could be a triangle? Can F be a triangle? Definitely not an isosceles triangle, but can it even be a triangle?
No.
No, can't be. G could be. Looks like the others probably, that's 3, yeah, that probably can be. But you have to apply that test to every single side. And usually when it fails for every single side also. In other words, if you try to figure out whether F can be a triangle, you fail immediately when you try to see whether does 1 pass the test, and it does not. It is not greater than the difference of the other two numbers.
Okay.
All right, we got to 32. Let's end it there.
Yeah.
Note here.
32 on the McGraw-Hill ACT test.
Yeah. 32 and the McGraw-Hill test. All right. And I guess I better put this date also.
The 6th February.
Yeah. All right. Great. Nick, I will talk to you, let's see, I think we have a Wednesday at 3:15, don't we?
Yeah.
Okay, I will talk to you then.
Okay, cool. Thank you.
All right, bye-bye.
Bye-bye.